In this video, we're going to go over rational exponents and radicals. Now, we've seen radicals before. Here's what a radical sign or a radical symbol looks like. Here's a problem. This radical symbol is simply a way of giving instructions with a simple symbol. Instead of having to write down a lot of instructions, we simply use this radical sign or radical symbol. Because if we had to write down the words, here's what the words would look like. This right here is telling me what two numbers multiplied together that are the same give you 16, and they only want you to write down one of those numbers. Now again, this symbol right here in words means all this. Instead of having to write down all these instructions, we have this symbol right here, this radical symbol. This radical symbol tells me what two numbers multiplied together that are the same, notice those two numbers have to be the same, give you 16. Only write one of those numbers down. So what are two numbers that multiply together to give me 16? Well, 2 and 8. But the two numbers have to be the same. What two numbers are the same, multiply together to give you 16? That would be 4 times 4. But how many of those numbers do I write down? Only one. What two numbers are exactly the same, multiply together to give me 25? 5. What two numbers are exactly the same that multiply together to give me 9? Only write one of them down. 3. 3 times 3 is 9. I only have to write one of them down. 5 times 5 is 25. These radical symbols are telling us to find numbers that multiply together to get the number up under the radical symbol. Now this symbol, a lot of times is called a square root. There's a reason it's called a square root. There's a number sitting right here that we don't see. There's actually a 2 right there. That's the reason the instructions are what two numbers multiply together. They can put different numbers there. This one is the cube root. Instead of finding two numbers that multiply together, they want you to find three numbers that multiply together. All three numbers have to be the same. Once they put a 4 right there, then it's just 4th root, a 5, 5th root. They put a 6 there, 6th root, 7th root, 8th root, so forth. These two have special names because these two actually exist in space. These are numbers that form squares. These are numbers that form cubes. So here are the names for these numbers. The number up under the radical symbol is the radicand. This number right here, the number that's being multiplied together, how many times is the index? And the symbol itself is a radical symbol or a radical sign. So this number right here is the index, and this one right here is the radicand. So if I'm going to find the cube root of 27, I need to find three numbers that are exactly the same that when I multiply them together, I get 27. 3 times 3 times 3 all equal 27, but the answer is only one of them written down. The cube root of 27 is 3, because 3 times 3 times 3 is 27. The 4th root of 16. I need to find four numbers that are exactly the same that when I multiply them together, I get 16. 2 times 2 times 2 times 2. 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. So my answer on this is 2. The 4th root of 16 is 2. Now when you're doing these, do not write these two numbers. Do not write a 2 as an index. Do not write an exponent of 1, because we're going to get into situations where they're going to want you to rewrite these from radical form to a different type of form. Do not write a 2 as an index. That means you don't have to put a 2 right here. And don't write exponents of 1. This is an example of something in radical form. It has a radical symbol. There's another way that you can write these. Another way of writing is called Rational Exponent Form. You're going to use a fraction. The fraction is going to have numbers in it that represent exponents and the index. And remember, the number that goes right here is the index. The way you write something in rational exponent form is you write down the radicand, the number up under the radical symbol. You make a fraction as an exponent. Your exponent goes into the top of the fraction, and the index goes in the bottom. So let's look at some examples of this. I'm going to change this one from radical form, because this is what it's in, to rational exponent form. First thing I do is write down my radicand, which is 13. I make a fraction. I put the exponent in the top. The exponent on this is a 2. And the index, which is 3, goes in the bottom. Another example. This is in radical form. I'm going to change it to rational exponent form. I write down the radicand first, make a fraction, put the exponent in the top of the fraction, the index in the bottom of the fraction. Next example. I'm going to change this from radical form to rational exponent form. I write down my radicand. I make my fraction. Remember, the exponent goes in the top. Remember, we don't write exponents of 1, so I can't see that exponent of 1 that's right there, but in this situation, I'm going to write the exponent of 1, and my index goes in the bottom. I'm going to change this from radical form to rational exponent form. I write down the radicand, I make a fraction. Exponents go in the top. I can't see an exponent, so it's an exponent of 1. The index right here goes in the bottom. Remember, we don't write indexes of 2, but we write it when we write it in rational exponent form. Next example. I'm going to change this from radical form to rational exponent form. I write down my radicand. I make a fraction. I put the exponent in the top, put the index in the bottom. It's okay if it is an improper fraction. Sometimes the exponent will be on the outside. Still do it the exact same way. Write down the radicand, make a fraction, put the exponent in the top, put the index in the bottom. On these problems, we're going to change them from rational exponent notation to radical form. My radicand is my big number, so I make a radical symbol. I put 5 up under it. This is my index. I put that right there. And my exponent goes right here. Or I could write the problem like this. Put my index here, 5, and then my exponent on the outside. Either one is acceptable. Next example. I'm going to change this to radical form. Make my radical symbol, put my radicand up under it, my index goes right here, my exponent goes right here. Again, I could rewrite it like this as well, using parentheses, and put the exponent on the outside. Next example. I'm going to change this to radical form. It means I need a radical symbol, put the radicand up under it, the index goes right here. And remember, I don't write exponents of 1. So this just stays like this. Do not write an exponent of 1. Next example. I'm going to change this to radical form. That means make a radical symbol, write the radicand up under it. This is an exponent of 1. I don't write an exponent of 1. This is an index of 2. I don't write an index of 2. So this one is simply going to look like this right here. The reason we change them from one form to the other is they're going to give it to us like this, and we may need to simplify or evaluate these. To simplify or evaluate this, I'm going to change this to radical form. I write down my radicand. I put my index right here. I don't have to write the exponent. I need to actually do the process or do the math here. I need to find 3 numbers that are exactly the same, that when I multiply them together, I get 125. And more than likely, it's going to be 5. 5 times 5 is 25, times 5 is 125. So my answer for this is simply 5. You change these around so that you can simplify these, and it might actually come out to be a whole number. So let's try the next one and see if this one comes out to be a whole number. I'm going to change this to radical form. I want to put my index right here, and I'm going to use parentheses. Why? hopefully I can actually find three numbers that are exactly the same that multiply to 27, and then I can square it. It'd be much more difficult for me to square 27, 27 times 27, and then find three numbers that multiply together to get whatever that number is. So maybe I can find three numbers that are exactly the same that multiply together to give me 27, and that will be 3. So inside here, I put 3, because 3 times 3 is 9, times 3 is 27. So the cube root of 27 is 3. Now I simply square that. 3 squared is 9. This one's already in radical form. The only thing I'm going to do is change where the exponent is located. I need to take the fourth root of 16. Are there four numbers that are exactly the same that multiply together to give me 16? That would be 2. That's 2 times 2 is 4, times 2 is 8, times 2 is 16. So inside the parentheses, I put 2. The 5 still goes on the outside. Now I need to do my exponents. That means I need to figure out what 2 times 2 times 2 times 2 times 2 is. 1, 2, 3, 4, 5. 2 times 2 is 4. 2 times 2 is 4. And then I bring down that 2. I got this by multiplying these together. I got this by multiplying these together. 4 times 4 is 16. And 16 times 2 is 32. This is another one that I need to rewrite to where there's parentheses. The cube root of negative 216, and then on the outside of it, I'm going to square it. I need three numbers that are exactly the same that multiply together to give me negative 216. Notice it says negative, so the numbers that I multiply together have to be negative. Negative 6 times negative 6 times negative 6. When I multiply all those together, a negative times a negative is a positive, times another negative is going to give me negative 216. So inside those parentheses, the cube root of negative 216 is negative 6. Then they want me to square that. Negative 6 squared, 36.